Hi, in this 2-video mini-series, I am going to talk about random numbers and entropy in Arduino. In this video, I will explain and demonstrate how Arduino's random number generation works, and in the next video I will list the ways which are available to us for getting better randomness or higher entropy in our projects. Let us begin with an example. For our next magic trick, we write an Arduino program that selects random cards from a deck. Here is the code. It has the names of all the card values, names of all the suits, a short setup, and, most importantly, a little loop that every 2 seconds selects and prints a random value and a random suit. Let's upload this to the Arduino Uno, which is currently connected to my computer. As you can see, this works, but it has a little problem. The cards we got here are Queen of Clubs, 6 of Hearts, 4 of Diamonds, 8 of Hearts, etc. If I reset the Arduino board, you will see that it picks the exact same cards in the exact same order. Suddenly, the random function doesn't look so random, does it? In fact, to the extent that we followed the sequence in the previous round, it has become completely predictable. And this can really destroy the element of surprise for our magic trick. So what's going on? To understand this, let me show you how random numbers are generated in Arduino software somewhere within built-in core libraries. We begin with a 32-bit number called the seed. This can be any number. However, when our Arduino programs start, it is automatically set to 1. Now, whenever we call the random function, the seed is multiplied by 16,807. Why? Because mathematics. Our program called random 13, so we divide this result by 13 and take the remainder, which is 11. As you can see, that's the index of Queen in the name list. We start counting at 0, of course. The same result, undivided, is then fed back as an updated seed. Let's see this again for the suit selection. When we call random, we multiply the seed, which is now 16,807, by 16,807. This gives us 282,475,249. The remainder from division by 4 is 1, which is exactly the index of clubs. So now you understand why our first card was Queen of Clubs. The result of the multiplication is then fed back into the seed, and the things will get a little trickier the next time around when the number will overflow beyond the 32 bits of the seed variable. But the principle is the same. It is an entirely deterministic process, and it is only random in the sense that without understanding this mechanism and without recording past runs, we are not able to predict the results that the random function will give us. This is actually what's called a pseudo-random number generator, or PRNG. We can change the seed whenever we want, using the function randomSeed. For example, I can write randomSeed 1000. This will set the seed to 1000. Note that a seed of 0 is useless, because when you multiply 0 by 16,807, it's still a 0. So if you write randomSeed 0, like so, the function will actually change it to 123,459,876. Why this value? Because I have no idea. But even if we define a new seed in our code, the process is still entirely deterministic. It will yield the same series of cards over and over again after every reset. To make things look really random, we need a way to generate a seed which no one, ourselves included, can predict. In other words, we need a reasonable source of entropy. This will be the topic of my next video in this mini-series, so stay tuned. Thank you for watching.